Hello, question 7 from the 2007 MAT. We've got, suppose we have a collection of tiles, each containing 2 strings of letters, one above the other. A match is a list of tiles from the given collection. Tiles may be used repeatedly such that the string of letters along the top is the same as the string of letters along the bottom. Right, okay, so they've given us an example collection here inside the set brackets. And this list is a match because it's got A, B, A at the top and A, B, A at the bottom. Okay, fine. Then they've given us a new set of these 6 tiles. What tile must a match begin with? So it's got to begin. So what have we got to have again for a match? We've got to have the same string top and bottom. So it needs to be starting with the same letter top and bottom, which is only this one with U's by the look of it. Yeah, because we've got X, U, Z, X, E, Z, Y, U, and Z, Y. So it's going to have to be the U one. So it's going to have to be U over U. That's the only way we can get it starting with the same letter. Write down all the matches which use 4 tiles, counting any repetitions. Counting any repetitions. All right. Oh, yeah, okay. So repetitions of strings, I suppose. I don't know. Well, let's put them all down and see what happens. So we've got U over U needs to be at the start. Then, we can do a similar thing for saying what it's going to end at as well, I'd imagine. So it's going to have to end with these E's. But we know we have to have another U at the bottom. So we could have the X over U or the Y over U, because we have to start U on both of them. So we could have X over U. We could have Y over U. Then we've got to have a X on the bottom for this one and a Y on the bottom for this one. That would have to be a Y, that would have to be an X. So we've only got Z over X and Z over Y. So those have got to be Zs. And then, well, we better be finishing off now, otherwise it's not going to be 4 tiles. So we'll have to have the EZE one. So EZE and EZE. So we just got those 2. That was fine. Suppose we replace the tile EZE with EZZZE. What is the least number of tiles that can be used in a match? Least number of tiles that can be used in a match. Right, okay. So we know that we've got to start with U over U. And we know we've got to end in E over Z, 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 E. So we've got to have, is it going to matter whether we go for the X or the Y on this? We've got X over U, Y over U, Z over X, Z over Y. So the X and Y are completely interchangeable on this because they've got the same tiles. For each one of them. So they're duplicates. It doesn't matter which one we go for. So we can have X over U here. We also know we've got to have a whole load of Zs. So if we're going with X's, let's just go with X's all the way through. And we've got to have Z over X, and then Z over X, and then Z over X. That gets us Z, 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 E at the end of each one. Then we've got to have more X's. Yeah, this isn't going to work, is it? I don't think. Well, let's keep going from the right-hand side. But I think, of course, we have got another option at the beginning. We don't have to go straight into having X over U. We could have U over U again. Anyway, we seem to be getting more fruitful results starting from the right-hand side because we now know that we've got to have an X, an X, and an X going along the top. And all of those have got to be over U's. So U, and U. So we've now got 3 U's we have to put at the top. Wow, okay. We could have, how many U's have we got here? We've got to build up on U's at the top. I mean, the only way we can get U's at the top is to do a U over U. That's the only way we get U's on top. So we've now got, we got 5 at the bottom and 4 at the top. So yeah, this isn't going to be X over U. That needs to be another U over U. Have we now got there? I think we have. So we've gone 1, 2, 3, 4, 5, 6 U's at the start. 1, 2, 3, 4, 5, 6 U's, top and bottom. Then 3 X's, 3 X's, 3 Z's, 3 Z's, and an E and an E. So yeah, it was a lot easier working this out from the right-hand side, because there was just no other way you could go about it if you started from the right. Whereas starting from the left, well, I took that wrong step by putting X over U in, it immediately became apparently wrong if we start from the right. Right, okay, so that was good. What is the least number of tiles? That was what they asked that can be used in a match. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 tiles. Okay. How many different matches are there using the smallest number of tiles? Oh dear, how many different matches? Right, so we're saying that the X's and the Y's are interchangeable. So these ones are all fixed. We haven't got any, yeah, we can't change those, but we can pair these up, can't we? We can pair up that one and that one are paired, aren't they? For X's, and that one and that one and that one and that one. So we've got 3 pairs. So we've got 3 pairs of X over U, Z over X. And we could change those around to be Y's. So we've got, yeah, 3 pairs. So you could change, so what I'm getting at with this, if this isn't clear, you could change that to a Y. If you change that to a Y, that would have to be a Y. So that's one way that we can change it. You could then change that one and that one and that one and that one. So we've got 3 pairs that we can either be X or Y. So that means we're going to have 2 to the power of 3 permutations to go through all of those. So they could be, all X, they could be all Y, and then they can be various, there's 6 other options in between. So we've got 8 different matches is our answer to that one, because we've got that 2 to the 3 permutations. Right, okay. What have we got? Oh, hint there. You may find it easiest to construct your matches backwards from right to left. Right, maybe I should have read ahead in the question. Although it was fairly apparent when we were doing this part that that was going to be the way to go. But they could have put that hint up here rather than after the next question mark, but there you go. Right, next bit then. Consider a new set of tiles, x, 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 or however many that was over x, and then x over loads of x's. So we've got 7 x's on top and 10 x's on the bottom. For which numbers n do there exist matches using n tiles? Right, so how are we going to put all of these together then? So we're combining. Well, it doesn't matter what order we put these tiles in because they're all x's. It's just how many of one of them do we have and how many of the other one do we have. So we're saying, so say we've got, well, let's say we've got A lots of first tile and B lots of the second tile. That means that we're going to have the numerator's got to equal the denominator, isn't it? So we've got A lots of the first tile, which means we'll have 7A x's on the top and just A lots of x's on the bottom. There, so that'll be the top, that'll be the bottom. Then we've got B lots of the second tile, so that'll be B there and 10B there. And these have got to be equal to each other. So I should have just written that out as an equation, really, shouldn't I? So 7A plus B is equal to 10B plus A. Right. So we've got that 6A is equal to 9B. A is equal to 3 over 2B. And A and B have both got to be integers, so we know that B is going to have to be an even, therefore B is even number. Right, so now what are we trying to do? We're trying to work out n. So what values, which numbers n do there exist matches? So n can be, so B is even, so say B was 2, then A would be 3. So we'd have n is equal to a plus b. So we've got b equals 2, means that a is equal to 3, means that n is equal to 5. If b was equal to 4, then we've got that a is equal to 6, which means that n is equal to 10. If b is equal to 6, then we've got 9. 6 and 9 is 15, right? So we're going up in 5s on all of this. So we've got n is a multiple of 5. Multiple of 5. Of 5. There we go. So, I mean, maybe we could have done that last part in a slightly different way then. So we said that n equals, really got any space on the screen? Let's go to green and just squeeze it somewhere in the middle. So n is a plus b. So we're saying that n equals 3 over 2b, so 1.5b plus b. So 5 over 2b, where b is even, which means that we're going to have, therefore, n is a multiple of 5, because we're just going to have this counted number multiplied by 5. N equals 5 times, you know, some number times c, where c equals b over 2. C equals b over 2. So yeah, that's the thing of b being even. So that brings us back to n is a multiple of 5 again. Maybe that was a slightly neater way of putting it in rather than just having all of these answers written out. Right, that was a pretty quick question, that one. I suppose they were just trying to confuse people with the weird notation of all of this. It's quite a lot to maybe assimilate for new information, but it was pretty straightforward sticking these things together. It was, yeah, it's quite nice though, isn't it? You don't want every question to be blowing your mind every time. So that brings the end of Matt 2007. Be back in 2008.